Hello everyone, this is Ex1. Today we are going to talk about the first lesson of this course, which is using Staad to find some answers to our example. Here, our example, as you can see, this is a beam. Okay, we have here 8 meters, 5 meters, 7 meters, and a distributed load of 20 kilonewton per meters and the self-weight. So we are supposed to find the joint displacement, member forces, and the support reactions. Okay, so let's get to it, right? Okay, so the first thing we need to open the Staad Pro. Okay, we hit a new project. Okay, so let's call it project 1. Use meters, kilonewtons, next, and add beam. Okay, so just one note before we continue. The previous lesson I've made an indication and gave some explanations about how to install the Staad Pro. So try to follow it literally to avoid any kind of problems, because if you didn't install it correctly, you are going to need to reinstall your Windows, which is a big problem. So try to follow the previous video correctly so you don't have such problems. Okay, so we hit finish and we have this view. So this is the three-dimensional view. We are seeking the two-dimensional view, which is the Y and X. So to choose that, we have here like 7 boxes, 7 icons of boxes. So we hit on the positive Z because this is the top view we are going to look from. Okay, so here Y and here X, and Z is going from out the screen. So to begin, we need to hit create. So choose a regular and give it a regular name. Okay, so we have here 8, 5, 7. They are the links we have for this beam. If we want to put those links on the Staad Pro, we are supposed to begin with 0. Remember that. We are supposed to begin with 0. 0, 8, 5, 7. 0, 8, 5, 7. Okay. And we hit OK and we choose it, as you can see. So from here to here to here to here, you need to draw it yourself. Okay? Okay. So the second thing we need to do now is, just let me see here. Okay. So we need to head to the general section. We have the property. Okay? So we need to make a definition here. So hit define and define your beam. Is your beam circular, rectangular, trapezoidal? Okay, so we are going to choose the rectangular. We have, just a second, let's see the example. We have the rectangular cross section of the beam with width of 0.7 and depth of 0.32 meters. Okay, so YD, which is the depth, is going to be 0.32, and this is going to be 0.7, okay, which is the width, and we hit add, then close. Now it's time to assign this definition to the beam. The thing is, I can do this 2 ways. Okay, the first method is I can choose the part of the beam that, or I can choose the beam that has this cross section, so I can hit assign, and here you go. But isn't there any practical way, because all of them have the same section? So instead of that, you can use the assign to view. Look, and it's so easy. It's a piece of cake. All right, so we have assigned them all. Okay, now what we need to, the next step we need to do is to make supports. So as you can see here, we have 1, 2, 3 penned supports and a fixed one. Alright, so we hit to the general support and we hit create. We have fixed one. Okay, we add one. No problems. Create another one. Come on. Okay, pinned, add, and here we go. So this is the fixed one. Okay, so we cannot use the assign to view because we have differences here. As I said, we have 3 penned and 1 fixed, so we hit on the fixed one, we hit on assign button. Okay, so here we have the fixed one, and for the penned one we use this one. right, and hit the assign button, and here you go. So easy, you see. So the next thing we do is we go to the loads and definitions. Okay, please save. Load case details. We hit add, and we just need to add one load case. Okay, because as you can see here, we only have this load case. We don't have something indicates that it's did load, live load. So we are going to use one load case for all the loads we have here. So we have the 20 kilonewton per meter, the distribution load, and the self weight. Okay, because it's not included, we need to add it. So we hit on the load case one, we hit the add, and we add the self weight. Okay, by default it's -1, and we go to the member load and we add the -20. So why minus? Why not 20? Because as you can see, it's going toward the minus y. So we have the positive y upside and the minus downside. Okay, and a global y, which is this. This is y, as you can see. So this is the global y. He's going to the minus global y. Okay, and we hit add. So we close it then. Self weight is assigned to the whole beam. Okay, so assign to view, assign. Okay, and the same as for the distribution load, as you can see, it's assigned to the entire beam. Okay, so assign to view. Okay, and here we go. We have assigned the forces. The next thing we need to do is to go to the tab which is an analysis print. We hit it, and we have perform analysis, no print, and add. We have here perform analysis. So we hit close, and we go to the analyze mode or tab. We hit run analyze and save. Yes, please. Let's see. Oh, very good. We have no problems. So you have three options: whether to stay in this mode, the one that we are working on, or to view the output file, or to go to the processing mode. For now, post-processing. We are going to choose this one, and we hit done. Okay. Oh, look at that. We have everything changed. So you can see we are in the node tab, NODE, node tab. The cursor, as you can see, has the node sign. Okay. So we need to see the displacement. We need to know about the displacement of the nodes. What we are going to do is we go to the results and hit on view value. Okay. Displacement. Annotate. Can you see? But we need to see like the curves. Okay, so we go to the results and scale. We change the displacement from 1000 to 10, and we hit enter. As you can see, here you go. So you want to know the reactions? Okay, we hit to the reactions button. As you can see here, we have on the Y, on the Y, on the Y, on the Y, and here we have moment. But here we don't, because they are pinned, but this one is fixed. Okay, so we head to the beam section. Alright, so if you want to know the shear, the moment for any of the three beams here, what you're supposed to do, just double click, go to the shear. Suppose we want to know the shear or the bending moment. Okay, so this one gives you the bending moment, and this one gives you the shear. Okay, so suppose that you want to know the shear force at 5. Okay, so you have here minus 16 kilonewton and minus moment. Yeah, so talking about the moment, Staad, as we know that we engineers, we draw on the tension side, right? We all do that. Okay, but Staad doesn't understand this way. We have here the black line. Can you see this black line? So anything below this black line is considered as negative for the Staad, and anything upside is considered as positive. So the thing is, when you take the moment from Staad, you need to take the absolute value, not the value given by Staad. Okay, so just to give you an extra information about it. Okay, so if you want to see the deflection, okay, as you can see here. Okay, so this is all what you can find about it. Not easy, just you need to be focusing on what you're doing. Okay, so let's go back to the modeling. Okay, sorry for that. Okay, just a second. Okay, so let's hit here. As you can see, if you want to go back to the post-processing, just hit this one. If you want to get back to the modeling, just hit this one. Okay, so how could you make sure that you have drawn this exercise or made it correctly? The lengths, okay, the spaces between them. So just hit on the tools and go to the dimensions beams, and you can see the display. Okay, oh, you see that? Okay, so you have also shear forces here. You have forces, moment over Z. You can view it from here without going to the post-processing from this tab. Okay. Moment X, F, Z, we don't have any of Z here. We have only Fy, and we have the moment of Z. So this is all what I got for this now. Okay, the last information I want to add is when can you add pin or nodes like this? When? So the three options I remember is when you have different section, when you have different material, and when you have a concentrated load. Okay, this is all what I have for this lesson. I hope you got good information and you got good understanding of how using Staad. So this is the basic and the first example for our course. I hope you have enjoyed it. Okay, and wait for me in the coming classes. Okay, thank you for your viewing. Bye bye.